Okay, so we're starting with linear regression. So linear regression is all about just trying to show a relationship between two things using the equation of a line. All right. So let's look at this example here. A small shop tracked its advertising, spending, and sales for 5 weeks as shown below. Okay, you have been given the week and you have been given the sales. All right. So the first question is, why should we draw a scatter plot? Okay, the reason why we draw a scatter plot is because we want to see visually if there's a relationship between the week and the sales. Okay, so a scatter plot is just like a graph. Okay, maybe I can even make the same scatter plot on Excel so that we see, okay, if there is a relationship between these two variables. Okay. Week is represented by X, sales 20, 25, 30, 35, 40. Okay, so if we plot this on a scatter plot, okay, yes, here, so on our x-axis, as you can see, we have the weeks. Okay, on the x-axis, we have the weeks. Oops, what have I done? And on the y-axis, we have the sales. Where is that graph going to? What has happened to that graph? Okay, but we saw that graph, right? You saw like the dots were going in an upward form. Okay, we saw the dots going up in an upward form. So the scatter plot, it shows if there is a relationship between the two variables, all right? So the way we saw those dots, let me just illustrate it here. When we drew the scatter plot, we saw the dots going up like this. Okay, so this indicates a positive relationship between the week and the sales. Okay, what we mean as a positive relationship, as the weeks are increasing, week 1, week 2, week 3, the sales are also increasing. Okay, so we saw a positive relationship with our scatter plot. Okay, it's not all the time that you see the dots straight like this. Sometimes they might be scattered. They might be like this, scattered. But if you can see an upward trend or a downward trend, then you'll be able to know, okay, there is either a positive relationship or there is a negative relationship. Okay, so the reason why we draw a scatter plot is we just want to visually see if there's a relationship between the two variables. Are we okay with that? Any questions? Okay. Next, we need to find the regression equation. Okay. the regression equation. As we can see, the equation is in this format: y equals a plus bx. Okay. A represents the intercept, all right, when our x value is 0. Okay, so when the weeks in week 0, how many cells do we make, basically, in this case? Okay, so the intercept is just showing you the value of y, which is your dependent variable, which is cells in this case, when the x variable or the weeks are 0. Okay, then this b represents the slope, the rate of change in y for each 1 unit change in x. So if x increases by 1 unit, how much will y increase by, basically? Okay, so if a week increases by 1, the cells have to increase by a certain amount again, according to the slope. All right, so this is the format of the equation. So what we need to do is we need to get our intercept and we need to get our slope. Okay, so first you start with the slope. This is the formula for the slope. Okay, it's the number of data values multiplied by the summation of x times y minus the summation of x, which is where you're just adding up all the x values, divided by the summation of y, where you're adding up all the y values, divided by the number of data values multiplied by the summation of x squared. Okay, each x value, you're squaring it, then you total it up, minus the summation of x squared, meaning the total of x, then you square it. Okay, so you need to be able to differentiate these two. Okay, so that's what we're going to get first. All right, so if you want, usually you can make a small table, okay, or you can just solve it like this. All right, our x values, which were the weeks, when we add them up, week 1, week 2, plus week 3, plus week 4, plus week 5, we get a total of 15. Okay, let me just bring back the table so that we'll be following closely. Okay. Yes, so summation of x, we're just adding these x values. 1 plus 2 plus 3 plus 4 plus 5. Right? We get 15. Okay. Summation of y, we're just adding 20 plus 25 plus 30 plus 35 plus 40. We get 150. Okay. Summation of x squared. Okay, we're squaring each of these. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, which is here. You get 55. Okay, then summation of xy, meaning you're multiplying each week by the cells. So you say 1 times 20 plus 2 times 25 plus 3 times 30 plus 4 times 35 plus 5 times 40, which is here, and you get 500. Any questions, colleagues? Okay, the process, just need to remember it. You add up all the x values, you add up all the y values, multiply x times y and add all of that, then square each of the x values and add them up. Okay, yes. Any questions? Oh, and n, the number of data values is 5, as you can see. 1 2, 3, 4, 5. So n is 5. Okay. Are there any questions before we put this in the formula? Okay, so I'll put this in the formula.
Now, sir.
Mhm.
I've got a paper, so I was thinking that maybe I share with you so that we go through it.
The paper questions are too long, won't be able to tabulate. Once you watch this video, you will be able to answer that paper question, because the way I formatted these questions, I saw the tutorial sheet. Now I just made the questions smaller so that we can cover more. Okay, yes, the original questions, they are big. You find maybe about 10 data values, 8, 9, so it might take time.
But they are just 5.
There are also 5.
Yes.
Okay, so after this video, you should even attempt that same one, okay? Because what you'll be doing, yes, it's the same thing you'll be doing in that question. So you can still share that tutorial, okay, madam, so that after we've done these preparations, you attempt those questions and you send me your answers.
Okay.
So we come into our formula here. N is 5. Summation of x times y is here, 500. Minus summation of x is 15. Summation of y, 150. So we are multiplying here. Divided by 5. N is 5. Summation of x squared, 55 here. Minus summation of x, which is this 15, and then you square it. So when you do your tabulations, 5 times 500, 2,500. 15 times 150, 2,250. 5 times 55, 275. 15 squared, 225. So our B, 2,500 minus 250, you get 250. 275 minus 225, you get 50. So our B is equal to 5. Any questions? That is our B, which is our slope, which is telling us when x increases by 1 unit, y will increase by 5 units. So we are seeing as each week is increasing, week 1, from week 1 to week 2, it increases by 5 units. From week 2 to week 3, 5 units. Have you seen? X is increasing by 1. Y is increasing by 5. Okay, that's what the slope is telling you. Okay, so we've got our slope. Any questions before we get our intercept? Okay, so for the intercept, there are 2 equations you can use. Okay, there is this one. You just get the average of y minus the slope multiplied by the average of x. Okay, this is the one I usually advise for. Okay, it makes life easy and it saves you time. Okay, the other one you can use is you can get the summation of y minus b multiplied by the summation of x divided by n. So the one I used is this one here. Okay. You get the same answer as if you use n. Okay. I tabulated what is the average for y. Remember y here, the total for y is 150. To get the average, we just divide this 150 by 5, since there are 5 numbers here. So to get the average, we just divide this 150 by 5. Okay. Even for x, to get the average for x, this 15, we just divide it by 5. Okay, colleagues, just get the average of x, get the average of y, and then you'll be able to get the intercept. Okay. So the average of x is 3. The average for y, 30. So our intercept a equals the average of y minus b, the average of x. Average for y was 30. B, which is our slope, is 5 multiplied by 3, which is the average of x. 5 times 3, that is 15. So 30 minus 15, that is 15. So what this slope is telling us is when the weeks are 0, on week 0, the cells are 15,000 or 15 million, whichever. Okay. When the weeks are 0, or on week 0, this is the cell. Okay. So since we've got A and B, remember our formula was bring it back here. The formula for the equation. Formula for the equation: A, we got 15, B, it was x. So our equation is y equals 15 plus 5x. So this equation is showing the relationship between the weeks and the cells, showing a mathematical relationship between the week and the cells. Okay. Yes. Now, colleagues, you've heard that phrase that correlation doesn't imply causation. You've heard that term before? What that means is, like for example here, we can see that the cells and the weeks, they've got a positive relationship. When the weeks grow, increase, the cells also increase. But even though they've got that relationship, we cannot just say that, the cells are affected by the weeks. No. Okay. We can't say the cause of the cells to increase is the number of weeks. We cannot come to that conclusion. We've just seen there is a relationship, but the weeks are not causing the cells. We cannot say the weeks are causing the cells to change. Okay. All we can say here is there is a relationship. Okay. And with this relationship, we can also now forecast, predict, okay, what our cells are going to be in the future. Okay. So as this part says, predict the cells for week 6. Okay. So x represents the number of weeks, y represents the cells. So want to predict what will be the cells for week 6. So where there's x, just replace it with a 6. Okay. So if we replace 6 where there was x, 5 times 6, that is 30. 30 plus 15, that is 45. So in week 6, we expect the cells to be 45,000 or 45 million. questions? Okay. So here, interpret the slope. So as each week increases, as the weeks increase by 1 unit, the sales also going to increase. The sales increase by 5 quarter or 5,000. Yes, that's the interpretation of the slope. Any questions? Okay, now next is want to find out how strong is this relationship between the sales and the weeks. Okay, this is where the correlation coefficient comes in. Okay, you want to find out how strong is this relationship. Anything less than 1, okay, it's not strong. But the closer you get to 1, the stronger the relationship. Okay, so if you've got a correlation coefficient of 0.1, you can say, okay, that relationship, it's a positive relationship. Since it's a positive relationship, just means it's an upward slope. So we're just testing how strong is this positive relationship. A negative R value is just talking about a negative slope, a negative relationship between the variables. So this is the scale of how you determine. Okay, if let's say for example an R of 0.1 versus an R over 0.9, if you have this one with a 0.9 shows there's a stronger positive relationship than the variables compared to this one, which is 0.1. Okay, so basically we formed an equation, but want to see how strong is the relationship of the variables. Okay, so here's the formula for getting our correlation coefficient. Okay, so we've got most of these values here. The only one we need to get is this summation of y squared, where we square our y values. Okay, where we square our y values. Okay, square each of the y values and then add them up, and you get 4,750. Okay, so when you reach this part, if it's in the test, you would have calculated most of the values. Summation of xy, we already have it. We have summation of x, we have this one, we have n, we have this, we have this. The only thing you need to calculate is this summation of y squared and summation of y squared. Excuse me. So I do the summation of y squared. Okay, I'll do it. It was done in the formula. So I just broke up the formula into parts. Okay, the denominator and the numerator. And so on the numerator, I'll just bring the formula here. This. You do your tabulation. So on the numerator, put it like this. You get 5 times 500, 2500. 5 times 15, 2250. This answer, let me move it aside. The denominator, five times 55, you get 275. 15 squared, 225. 5 times 4750, 23,750. Then 150 squared, this was our summation of y, it was 150, then we square it, becomes 22,500. So now numerator we get 250. On our denominator, when we do everything, when we multiply, subtract 275 minus 225, we get 50. Mm-hmm. 275 minus 225, you get 50. 2,750 minus 2,500, you get 1,250. Then 50 times 1,250, you get 62,500. Okay. The square root of 62,500 is 250. Divided by 250, you get a correlation coefficient over 1, which means this is a very strong relationship. Okay. In real life, it's rare to get this. Okay, the way I modeled this question, it showed that we get a strong relationship. Okay, if you get an error of 1, there is a strong positive relationship between the number of weeks and the cells. Okay, there is a very strong positive relationship. Yes. Any questions?
Yes, sir. Just want to take you back. You say that the use of a scatter plot on your regression analysis is for what?
To give you a visual representation to see if there's a relationship between the variables.
So the relationship between the variables?
Yes.
Okay.
So if you see, if you plot and you see your scatter plot is like this. Here.
So can you use that like in the standard deviation?
What do you mean in standard
The
deviation?
data point.
Wait, what are you? Can you use what in the standard deviation?
Like in those data cells, you say that if you know the data cells, if they are what? I was just comparing the use of standard deviation in statistics. Can it be the same like for standard deviation?
No, standard deviation is how spread out are the data points from the mean.
Oh, okay.
That's the yes. So as I was explaining, if you see your scatter plot is like this, it means there is like no relationship here. Okay, if you try to draw a straight line, it's just like this. There's no relationship. Okay, if you see a scatter plot like this, and here you can say, okay, here there's a negative relationship between the two variables. As one is increasing, the other one is decreasing. So here there's a negative relationship. Okay, you can even draw them. When you form your equation, this will be the equation of your line like this. Now in our case, in this question, we saw the points were like this, straight. Week 1 it was 20. Week 2 it was 25. So we saw here there's a positive relationship. Okay, week 3 it was 30.